All right, this is Math 209 Week 3. We're doing section 8.4, still talking about domain and range. All right, so remember that, oh dang, everything's beeping at me. Remember that domain is all your x values and that the range is all your y values, okay? And so when we say find the domain of this expression, what we're saying is find all the values that x is allowed to be. So when we look at the graph, you'll notice this graph is really kind of funky. You'll notice that you've got this curvy thing going down here, and you've got this curvy thing down here, and you'll notice that right here at -6, it never quite touches. So it keeps going up, and so that red line gets close, infinitely close, infinitely close, infinitely close, but it never touches the -6. The x equals -6. And down here, that the closer you get to it never gets to -6. So the x value is right here, and you're allowed to be anything down here in the negative infinities. You're allowed to be anything up here in the positive infinities. The one big, huge exception is that x is never allowed to be -6. So there's this gap right there at -6. So there's like a hole. And that's not a zero, that's a hole. That shows that x is allowed to be everything on the negative side. X is allowed to be everything on the positive side, with the exception right here of -6. So how do we write that? Well, we say, we say everything from the negative infinities up to -6. We do a soft bracket because it's not actually allowed to be -6, and I'll show you why in a second. And then on this side, you're allowed to be everything above -6 all the way up to positive infinity. And again, we want the soft brackets, not the hard brackets. And since it's like in two sections, right? X can be down here and x can be up here. We use this thing called the union symbol. And that says, so x is allowed to be anything down here, and x is allowed to be anything up there. And so over here, we're going to write that. So it's negative, negative infinity up to -6, the union symbol, and that's this symbol right there. By the way, if you want to type in the infinity symbol, it's right there. And then it's from -6 up to positive infinity. So this is what you're going to write. Now, what's the significance of the -6? Well, if you look at your fraction, a fraction is never allowed to have 0 in the denominator. So if you're looking at that denominator, you can never have 0 down here. So what would make this 0? Well, if x was equal to -6, that would make this denominator 0. And that's a big old huge no-no. The denominator is never allowed to be 0. So that means x can never, ever, ever, ever equal 6. All right, and that's why our domain looks like this. It could be everything on the negative side. It could be everything on the positive side, except you're never allowed to be 6. Another way we could write this is you can have your, let's say -6, -7, -8, -9. Then we'll go up -5, -4, -3, -2, etc. We could, if we wanted to, we could put a circle around 6, and then we could do a big old thick arrow going this way because it's allowed, x is allowed to be anything down there, and x is allowed to be anything up here. And so that's another way to think of this. Everything down here, everything up here, except you're not allowed to be -6. All right, so we are being asked to find the domain of this function. And remember that domain is all the values that x is allowed to be. So what I like to do is I like to take that equation, I like to put it into Desmos. So I'm going to graph it over here in Desmos, and you'll get this really cool graph. And you'll notice down here for our x values, that something special happens right here at 5. Something happens right there. And what happens is that's where x is never allowed to be 5. So you've got 3, you've got 4, you've got 5, 6, 7, and you'll notice this is called an asymptote. And what that means is the closer you get to 5, the higher the value of y becomes, and then the closer you reach 5 on this side, the lower the value of y becomes, so that what really is happening is x is never, ever, ever allowed to be 5. And now why is that? Why is x never allowed to be 5? Well, if you look at the equation, if x was equal to 5, if x was equal to 5, you would have 5 times 5 minus 25 in the denominator, and that makes 25 minus 25, which is 0. If x was equal to 5, the denominator would be equal to a big old fat 0, and that's against the law. So x is not allowed to be 5. So x is not allowed to be 5. So how do you write that as your range? Well, if x is not allowed to be 5, but it could be everything else. So it could be all of these negative numbers, everything down to -infinity. And it could go all the way up to 5, but it can't equal 5. So that's why it's a soft bracket. And it's the union symbol. X is allowed to be everything from 5 up to +infinity, but it's not allowed to be 5, and it will never reach +infinity. So this is your interval notation. So what does that mean? That our interval notation is, and again, you're going to be using these symbols over here. So x is allowed to be from -infinity up to 5, and so the negative infinity, or the symbol for infinity, is right there. So you're going to type in the negative sign, and then you're going to press the infinity symbol, comma 5, and then plus the union, so that's this symbol right there. And then it could be from 5 up to infinity, but it's going to be soft brackets on those because it's not allowed to be 5, and you'll never reach infinity. So that's why that is your answer. And this one's a cool, cool picture. So once again, we're supposed to be finding the domain, which is the x value. It says find the domain. And so what we're going to be doing is looking for the values of x. Now, when you graph it and you look at the equation on in Desmos, you're going to get this really cool figure. I love it, I love it, I love it. So it's this thing that goes here, and then it drops down. And then it kind of makes a U right here. And then it goes again right here. So it's this disconnect. And you get this disconnect right here. And then you get another disconnect right here. Well, if you look carefully at your numbers, here's -20, -10, and 0. This spot right here, that disconnect, happens at -5, right there. And then the other disconnect happens right here at positive 5. So what that's saying is x is allowed to be anything down here on the negative side, except it's not allowed to be negative 5. And then x is allowed to be everything in the middle, except it's not allowed to be positive 5. And then x is allowed to be anything on the positive side. Okay, so you've got these three intervals. You've got this low interval in the negatives, you've got this in-between interval, and you've got this upper interval on the positive side. So how do you write that? Well, it's going to have, so let's talk about this section. Oops. Let's talk about this section down here. So it's negative 5 all the way down to negative infinity, and we're going to put our brackets right there. So that's this section down here. This section goes from negative 5 up to positive 5, but it's not allowed to be either of those. So it's the soft brackets rather than that hard bracket. And then on this side up here, it starts at 5 and it goes all the way up to positive infinity, but we're going to have soft brackets on both of those because you're not allowed to be 5 and you'll never reach positive 8. So we've got these three intervals. And so we're going to go over here. Now, how do we write that as in our interval notation? How do we write that in interval notation? Well, you write that like this. Here's our three intervals that I had talked about earlier. And our three intervals, and then you use the union symbol. And by the way, we're not going to use the intersection symbol, I don't think. And so you insert the union symbol right there, and that is your answer.